Let's look at Java's String.compareTo method. Now, some of the ways that compare_to works are obvious, and some of them are not so obvious. So let's say that S1 is equal to A, and S2 is equal to B. Now, obviously, S1 comes before S2. We can all see that. And if I call S1.compareTo S2, Java sends me back the value -1. The negative here just means that S1 is before or smaller than S2. And that makes sense, right? S1 is A, we would want S1 to go before S2, B, if we were going to sort a big list of strings like this. So the negative here just means that A comes first. Let's switch them up and compare B to A. Now B is obviously after A, and Java's going to tell us this by just flipping the sign on the result we just saw. Instead of -1, we get back +1. So a positive number means that this string comes after or is bigger than the string we're comparing it to, and it's going to come after that when we sort a big list of these as well. Now what if they're equal? A little less obvious here, but if a positive number means that this string is bigger, and a negative means this string is smaller, then a 0 is going to mean they're equal. Now what about A versus capital A? In a dictionary, these would go in about the same place, so you might expect a 0. Or you might expect a very small difference like +1, -1, since they'd be very close together. But actually what we're going to see is 32. 32 is what we see. Now, why 32? Where does that even come from? I could make a whole video about this, I'm just going to cut to the point. Basically, there's a big table that people made some decades ago that records how each letter maps to a given binary number. And when we do compare_to, we're kind of subtracting these numbers. And basically, lowercase a is 32 spots later in the table than capital A. Now, knowing exactly how far apart different letters and characters are in this table is not that important here. Your real takeaway is that compare_to can have kind of unintuitive weird behavior that you need to be aware of. And that's what we're doing here. Your other takeaway is that, again, negative means that this string, S1, is smaller than the other string and goes first in a sorted list, and a positive integer returned from compare_to means the opposite. This string, S1, is bigger than the string you're comparing it to and goes after it in a sorted list. Now let's look at ask versus Bryan. Now ask obviously goes before Bryan, so when I say S1.compareTo S2, I'm going to see a negative result here. No, I see a positive result here. What's going on? So it's not just that lowercase a comes after capital A. Actually, all of the capital letters come before all of the lowercase letters. So ask spelled with a lowercase a comes after Bryan with a capital B. Now, if you don't like that behavior and you do want ask to go before Bryan in your sorted list, you're just going to use compare_to ignores case instead of the default compare_to method. But you do have to explicitly code that in. So just be aware of that. And also be aware that ignoring case is not going to remove all of the unexpected kind of weird behavior. So here, for example, we've got two strings that look pretty equal. What do you think I'm going to see if I compare them? I'm going to see -1. You might have thought we get a 0 because they look pretty much the same, and they're pretty much the same, but one of them has an extra space at the end, and if all other things are equal, the shorter string will go first, and that does include white space as part of that length consideration. So if 9 and 100 were numbers, we'd expect 100 to go after 9 in the sorted order. However, these are not numbers, they're strings. So what do you think we'll see when we do S1.compareTo S2? Will we see a positive, a negative, or 0? So we're going to see a positive result here. And the reason is that when we compare strings, we're going to treat digits as letters. What I mean is that we're going to treat any string starting with a 1 of any length as coming before any string of any length that starts with a 2, and any string starting with a 2 before any string starting with a 3 or 4 or 5, and so on. It's just the same idea as any word starting with lowercase a is going to come before anything that starts with lowercase b or c or d or f or whatever. And so S1 starts with a 9, so it's going to go after any string including 100 that starts with a 1, so we see a positive number here indicating that S1 is bigger or comes later in the sorted order. Now our final case for compare_to is going to be, what if S2 is null? Will I see a positive number, a negative number, or maybe just a 0. Actually, I don't see any of those. If S2 is null, the whole thing crashes. And if S1 is null, that's not on the chart, but that's just going to cause a null pointer exception. So if either S1 or S2 is null, you're going to have a crash.